Hello and welcome. So we have a circle, and we're told that CD, a little segment right there, is the diameter, and we're told the measure of angle DEB, which is going to be that little sliver right there, is a 65-degree angle. All right, let me rewrite that. It's a little easier to see. 65 degrees, there we go. Okay, and we're essentially asked to find all this other stuff right here. Well, first off, let's kind of remind ourselves of a few things. First off, we've got central and inscribed angles. Remember, a central angle is any angle at the center of the circle matches the arc it creates. So if the central angle is 40 degrees, measure the arc, also 40. Inscribed angle comes from an angle formed at the circumference of the circle, right? So a point on the outside of the circle. Okay, and essentially what that means that whatever the angle is, the measure of its arc is double. So if you have an angle that's 20 degrees, then the measure of the arc is 40 degrees, all right? Or you could half the arc to find the angle. So double the angle, get the arc. Half the arc, get the angle. Okay? So as we're looking at this one here, if we were to continue extending, right, the two lines that form the angle, we'd end up with this arc right here. So point E is a point on the circle. That's an inscribed angle. So if we take 65 and we double that, we'll end up with the measure of the arc, which is 130 degrees. Okay, and then from there we'd say, all right, well, what can we do with that? Well, we've used our 65. Let's see if we can do anything with CD being a diameter. Well, if this is a diameter, how does knowing 130 degrees help us? Well, think about it. A diameter cuts a circle in half. If a circle is 360 degrees, the diameter cuts it into two equal parts of 180 degrees each, right? Half of 360, 180. That means that this entire section right here is half of the circle. It's 180 degrees. And if we know that this portion of the circle is 130 degrees, that means that the remaining portion right here has to be 50 degrees. It has to, because the whole thing has to be 180 together. All right, so there you go. That would be that section of that. What if we wanted to find the inscribed angle that forms that? Well, we can come right back down here. And we can say, all right, well, we know the inscribed angle is half of the arc, so that should be half of 50, which is 25. That's an option. Okay, so let's start filling in any more information, see if it asks us for anything more. So first off, we're told arc DB, that's our blue arc right there, 130 degrees. The arc from C to B, we just found is that yellow arc, 50 degrees. And then angle CEB, we just said was 25 degrees. And now it's asking for the angle DCB. So DCB would be this angle right here. If we wanted to find that angle, we just extend to find the arc, which we'll notice is the exact same as our blue arc. Well, it's the same arc, meaning that the inscribed angle should be the same. In fact, it will be the same. That's just a definition. Okay, you could also just do half of the arc, get the angle, 130 divided by 2. We get 65 degrees. And then we have the measure of arc DCB. Alright, so let me take out these highlighters, a little easier to see here. So we started D, we'll have to go to C next and end at B. So DCB would be that arc right there. Well, notice that's most of the circle. It's everything except for that 130 there. So what we could do is we could take 360 and subtract 130, and that'll give us what we need. And you can find 230 as that degree measure. Or alternatively, what you could do is you could say, all right, well, we could just add all of those purple arcs together. We know that because it's on the same side of a diameter, right? This is a diameter. That's 180 degrees right there. So that whole thing is 180 from here all the way over, plus the 50. So 180 plus 50, also 230. Okay? It's another way to go about it. And that's it. That's as much as you can find on this one. Thanks for watching.